everyone, my name is Varnali Bhattacharya and I am a student of MTech IT of 4th Sem. For today's video, we're going to solve the question number 2 and, and let's get started. Write the algorithm for the Gauss elimination method with my-working. Now what is Gauss elimination method? We have to consider we have some linear equations. Linear equation that we have to solve. Now to solve all these linear equation simultaneously, we would just add them. I mean, not exactly add them. We would just uh, uh, I mean, and we would just use them as a matrix and convert them in a linear system so that we could gradually eliminate all the unknowns from the equation until and unless we reach an equation where it would be only one equation and with only one unknown. Now this whole process of the whole process of solving the linear system that we have discussed now is known as Gaussian elimination method. Now how do you do that? Now as you can see here, we have some simple linear system that you can see as x1 x2 plus x1 plus x2 plus x3 is equals to 6 2x1 plus 3x2 plus 4x3 is equals to 20, 3x1 plus 4x2 plus 2x3 is equals to 70. Now we would take all the coefficient from the linear system and convert it into a matrix. As you can see here, that is 1 2 3 1 3 4 1 4 2 6 20 and 17 augmented matrix that you can see here. Now the next step, we always know you have to do some row operation. Now to do the row operation, we have certain rule. The rule is to create upper triangular form. Now what exactly is the upper triangular form? We would take starting two columns, like the first column and the second column. As there are three equations here, we would take two coefficient of the first column and one coefficient from the second column. We would as you can see there, when we do a row operation of 4 to r2 as you can see here, r2 is equals to r2 minus 2 by 1 r1, r3 minus r3 by 1 r1. After doing this whole row operation, we can see there is a 0 and a 0 in the first column. The position here is said to be A1, 2, and here is A1, 3. So this is the whole of this is the position where we have to do the 0. This is if this was in 3 if there were 4 linear equations, we would just take the first column would have 3 arguments, and the three position in the first column would be 0, then 2, then 1. We would create this as a triangle, and so you can see here that the next 0 that we have taken is of A2, 3. As you can see here, we have zeroed the position of A2, 3. So by doing all the row operation, we would create 0, 0 in the first column and 0 in the next column. So this would create a upper triangular form. So after doing this, we would just solve it like a normal normally with the back substitution to get our desired result, which is minus 3. We would get the value of x1, x3, x2 and x1, so that we could finally get the result of our linear system. Now during this row operation, when we make the upper triangular face, I mean this upper triangular form, we are encountered with some problems. Now, what exactly is this problem? We will now discuss that. For this, the serious problem with Gauss elimination process is when we divide, we have we have divided some divided diagonal terms while converting the argumented matrix into a upper triangular form. Now this is what we have done in the row operation that we have seen. Now when we do this, I mean when we create the upper triangular form, uh, if the diagonal element is 0 or is vanishingly very small, uh, then the elements of the row below this, I mean the below the diagonal element would become very large in magnitude, and we would have a very difficult difficult problem to handle, because now the storage capacity of the computer cannot handle this situation. I mean the difficult situation, I mean the large magnitude that we have now, it cannot be handled by the storage capacity of the computer. Now to solve this problem, we have pivoting. Now to convert this problem that you have written here, we convert the system such that the element that has large magnitude in the column comes at the pivotal position, that is the diagonal position. Now to see this, you have for the next slide we have uh, partial pivoting that we would see. Partial pivoting, if only row interchanging is used to bring the element of large. Partial pivoting is used use when we just interchange the rows which has a larger magnitude when it comes to coefficient. So as you can see here, we firstly had x1, and here you can see, let me just do this. Here you can see x1 and 2x1, and so this would so you can see the coefficient in this in the second equation is lesser than the coefficient in the third equation. So we would just interchange the second equation with the third equation, so that we could answer the so that it could be a pivotal column. And as it is written, if only row interchanging is used to bring the element of large magnitude of the pivotal column to the pivotal position at each step of diagonalization, so then such a process is called partial pivoting. Now there is an augmented vector matrix from the linear I mean to say linear system. Here we have created the augmented matrix. Then we have done some row operations that you can see an upper triangular form that you can see 3 3 4 20, and we would interchange the row 2 and 3. I mean we would interchange the 2x1, the 2x1 will go in the place of equation 2, and the equation 2 would come at the place of equation 3. Such a method would be known as partial pivoting. On to the next part, that is complete pivoting. That is in this process of larger element, in complete pivoting, we would use the largest element, which has in terms of the magnitude. We In this process, the largest element of the whole coefficient matrix A is brought at 1 position of the coefficient matrix. Then leaving the first row and first column, the largest among the remaining element is brought to the pivotal 2 by 2 position. So on by using both row and column transformation is called complete pivoting. Now, complete pivoting is said to have when we have the largest element, we would just shift it to the 1x1 position of the coefficient matrix. Now, when we have after the largest element, we would take the second largest element, and the second largest among the all the remaining elements, we would just shift that second largest to the pivotal position 2x2, and so on. We would just go so on. We would just use both row and column transformation to get the complete pivoting. Now on to the algorithm, that is the main question. We shall consider three equation that is being given here, that you can see. Then we would just eliminate the a11. We would eliminate the first, you can see here, as you can see, we have a11, I'm sorry, a11x1. We would eliminate this coefficient, and to do that we are doing this process, this equation that we have generated to eliminate the a11 equation. Now we would simultaneously we would take another step, like when we have already done this, right? A11, we would just eliminate the first coefficient. Then after doing this, we would eliminate the second coefficient, like and this is the process of doing so. I'm sorry for this. We have the process here. Now we would call the a2 by 1. We had a structure here. This was a1 by 2, a by 1, a1 by a11, a1 by 3 by a1, a1 by 4 by 1, a1. So we would consider this as an constant k2 and rewrite the whole equation here. We would firstly take it k2, k3 and so on, so that we would get a equation like a whole equation like this. Now onto the algorithm that we have to make sure that we have to write, that is now to put everything that we have learned in the algorithm. Firstly we have to read a number of variable, which is by the way, if we take the linear equation from here, linear system from here. If we take the linear system from here, we would the number of variable there are 5. And on to the next step, which the first step of algorithm is to create a loop of for I is equals to 1 until it for I is equals to 1 towards 5. 1 to 5 the for loop will go on, and then again a j, an inner loop of 1 to n plus 6 in steps of 1 2, and during this loop we would read the value of our matrix. We would take all the coefficient value that we have from the linear system. After reading the value, the next step is to start from k is equals to 1 to n minus 1. Doing so, we would just start with the pivoting element. Now that we have read all the coefficient and met with the whole matrix, we have to now make sure, now we have to do all the row operation. Now during row operation, we have to take care of the situation that was pivoting, and so during the triangulation, we would just add up the pivoting. So after reading, we would again run a loop from for k is equals to 1 to n minus 1 in steps of 1 to, and then max the value of it. I mean, we would just max the value and put it in P, and then again we would take the pivoting element. Now that we have created the pivoting element, we would just make sure that we run another loop of m is equals to k plus 1, so that uh, we could check for the largest one. I mean, for the pivoting, we you need to know all the larger elements so that we could decide on the pivotal position. And so to do that, we would just run a loop of run a loop here. I'm sorry, let's not do that. As you can see here that we have for m is equals to k plus 1 to n in step of I do. If this is max, then begin. We have to begin, and if it is max, then we would and then we would just associate the value of a m k to the max, and then n would be p, so that we would get the maximum value, the largest value in the equation. I mean, the largest element in regards to the magnitude. After doing this, we would get a, if max is equals to e, then begin with the ill condition, and we, if there are some during pivoting we manage to encounter some ill condition equation. Now to avoid that, we would take another if condition, so that it could help us with the ill conditions that we have during all this elimination method. After doing that, we will just take the largest element to the pivot position that I have already. During the complete pivoting, what we have learned that we take the largest element to the first, I mean the first position, that was 1 into 1 position. And so to do that, we will just run this else part, and then a for loop that is q is equals to k to n plus 1 n steps of 1, and then we would do some swapping with the swapping function, that is 10k q a k q, which would give the assign the value of a p q, and a temp would assign the value of a p q, and this would end up with the uh, pivoting. So on to the next part, that is onto the next part, that would be, now after pivoting, now we can continue the process that was a row operation that we were doing. We managed to do all the we managed to solve the problem that have arisen during upper triangularization form. During this triangularization, the next part is for I is equals to k1 k plus 1 to n in step of 1 2, and we had some value, right? We have generated a value of k2, we have generated a value of k3 that we have seen in earlier part of the video. So now now we are doing that in the algorithm. I mean, we have taken all the positions, now we have all the coefficients, now we will just divide them and get our desired constant to generate the equation. As you can see here, for I is equals to k1 plus 1 to n in step of 1 do, and we will just we have created the coefficient, I mean the constant. Now the constant is used to create our whole equation that we have generated before starting the algorithm that I have managed to tell you. Now we have done all the row operation. Now this next step was our back substitution. so after doing all the forward elimination with pivoting, now onto the last step, which is back substitution, so that we could get the answer of our x1, x2, and x3, and all the variables that we have known till now. And so x1 xn is equals to a n n plus 1 by a n n, and so you can see here the whole back substitution method is given, and with this we solve the whole question number 2a, which was Gauss elimination with pivoting. Question number 2, part C. Write 4 disadvantages of Gauss elimination and 3 advantages of iterative method over the elimination method. First, disadvantage of Gauss elimination. The first reason is computational efforts. Now, in comparison to the iterative methods, the computational efforts of elimination method is 2n to the power 3 by 3, which is 2n square for iterative method. As the computational effort is decreased, the convergence will also decrease. For the next reason, we have the amount of bookkeeping is considerably very necessary. The amount of bookkeeping, I mean, what do you actually mean by bookkeeping? Which is row interchanges. Now, when we encounter all the problems like creating the upper triangular form, we generally require all the row interchanges to get our desired result. And if we do not have those row interchanges, we would never solve the problem done by all the larger magnitude element. And so the amount of bookkeeping is very necessary with respect to the Gauss elimination method. For the third point, we have the rounding errors may become quite large, particularly for ill condition. Now, rounding errors that we encounter, numerical arithmetic errors that we always encounter during all the computational values, are generally very high, and when it comes to Gauss elimination, it is quite particularly very high, and so it is a disadvantage. When now for the fourth problem, we have any special structure in the matrix of coefficient is difficult to preserve during elimination. Now, any special structure in the matrix is said to be of coefficient is very difficult to preserve, as when we do elimination we might encounter more zeros. I mean, we would have more zeros, and so when we multiply those zeros, we won't be able to conserve all the coefficient that we have, and so the special structure of the matrix of coefficient would be disturbed, and it would not give us a desired result. On to the next part, which is the advantages of iterative methods. Now, computational effort, I have already discussed. The computational effort is way much higher in consideration to the Gauss elimination method, and so we could say the computational effort is approximately 2n to the power 2 arithmetic operation per iteration, and if convergence is achieved in less than n iteration, it is significantly superior compared to the elimination method. So you can see the convergence is much higher when it comes to iterative method. For the second important advantage, we could say is the small rounding error. The rounding error that we encounter in the iterative method. Now, iterative method have small rounding error. As we do that process several times, so as we process it many times, the error would also be smaller every time. So when after doing all the iteration, the now the rounding error would also be very small, as the value is also very accurate, as we have already done like 4 to 5 iteration. So the rounding error being the one committed is the last iteration. Thus for ill condition, an iterative method is a good choice. Ill condition, when we do elimination, we have we have to do all the row interchanges, and so the coefficient might not be the one that we required. We can lose that to all the zeros that we have taken. And so now in the iterative method, we are not losing any of the unknowns. We would just use those unknowns to get our calculated value. And so now it could be better for all the ill conditioned systems that we have generated here. And for the third advantage, in the iterative method, we have seen that x1 set to be the newly calculated value of iterate in 10. Now if the set x1 is x1, now you can see here there is an equation that is xi xi plus w into 10 minus x1. If we put the value of 1 is equals to, we put the value of w as 1, we would get the equation like x1 assigning the value of 10. Now if we put w is equals to 0, we would just assign the value of x1 into x1. So we can see that if we are given an intermediate value between 0 and 1, convergence of the iterative method is very faster. And so we cannot actually find the value of w, as we have to find it by the trial and error. So the acceleration of the iterative value is quite attractive, considering our Gauss elimination method. And with this, we just completed the question number 3. Thank you.